Simultaneous equation is two equations together, and we need to find out what it is the same. So first of all, we have two equations first, 3x plus 2 and y equals to x minus 4. All right, with that, with the skills previously we have learned, we could go through the equation, which change it into y equals to mx plus c. Remember, y equals to mx plus c. M is the gradient, c is the intercept. So we have two equations here, 1, 2. Equation 1, y equals to 3x plus 2. So gradient is 3, which is up 3, run 1. All right, 3 over 1 is 3. All right, and the y-intercept is 2. Second equation, y equals to x minus 4. Gradient is 1, because 1 times x. And the y-intercept is negative 4. Now we've got all our information, then we're going to sketch a graph. Yes, graph paper again. Isn't that exciting? I'm going to love graph paper so much. Right, so we have our equation here. We just draw the axis. Nice and easy. That's a thick one. Let's use a thick pencil for the gradient, for the x-axis, and right, y-axis. No, x and y. Okay, I mixed it wrong. All right, so first of all, we have equation 1, y equals to 3x plus 2. So I have 1, 0 is here, 1, 2. 2 is here, and then for every going up, rise 3, go up 1. So 1, 2, 3. This is 5, and this is 1. So I got the equation here. I'm going to label it so that I know which one I'm talking about. All right, now we do the second one, y equals to x minus 4. All right, y equals to x minus 4, look at the information. Gradient is 1, intercept is negative 4. So 1, 2, 3, 4. It starts from here, and then for every 1 unit, it moves right. So I got the equation here, and then I got a few more points there. So I'm going to join the line together. Since the line should go to infinity, y equals to x minus 4. All right, and both lines should go through infinity, so I keep drawing it, extending the line. And that we got our intersecting point, if you can see it here. All right, so I extend the counting here, the axis. So negative 1, 2, 3, negative 3 is here, and the point is here. So negative 4, 5, 6, 7. Therefore, our coordinate, our intersecting point is negative 3, negative 7. So we can go back and say that, therefore, the answer of these two equations is when x equals to negative 3, y equals to negative 4 is the solution. Which means that when the two lines intersect each other, they have the same x and y. So this is how we solve the simultaneous equation graphically. Yeah, this is the graph. Graphically, we find the answer. We just have to write the intersecting point and then write the answer. And here we go. We could also solving the simultaneous equation by equaling the y. So we can do something with it. So y equals to x plus 1 and y equals to 2x minus 3. All right, this is the equation here. So if we write it because it's simultaneous equation, we are expecting to find the x and y, the intersecting point of the x and y. So, which means that if we assume that the x together, then the y could be found. So this is y equals to and y equals to. If I rewrite it, I can do it like this. Because this equals to y, y equals to this. So they are equal. Because of they are equal, we can omit that. So we have x plus 1 equals to 2x minus 3. And so we can now work on our simple equation. So minus x on the both sides. We have 1 equals to x minus 3, and I plus 3 on the both sides. So I have 4 equals to x. Therefore, after I find x, I need to find y. So I substitute this into either of them. So I will have y equals to x plus 1. So when x equals to 4, we substitute that in. So 4 plus 1. Therefore, we'll be able to find 5. Then we can answer the question. Therefore, the solution is x equals to 4 and y equals to 5. It's just nice and easy. All right, solving some simultaneous equation by substitution. So we need to substitute one thing to the others. So for example, we got 4x plus 3y equals to negative 14 and y equals to negative 3x minus 3. So we can do that by substituting inside. So let's do it. And right, so we're putting 2 into 1. So we're putting that inside. So we have 4x plus 3. Replace the y with y equals to negative 14. But now we do not want the y. We want whatever y equals to. So we have negative 3x minus 3. Okay, so, and then we expand it. Make sure you multiply by all of them. So we have 4x, 3 times minus 3 is minus 9x. Minus 9 equals to negative 14. Alright, it's a bit dirty there. Right, so we have negative 5x minus 9 equals to negative 14. So if I remove the 9 to the other side, it should be negative 5. So I divide both sides by negative 5, then I will get negative 1. But it's not finished yet, we need to find y too. So we put y equals to negative 3x minus 3, yeah? So now we remove the x, we put negative 1 in, because x equals to negative 1. So negative 3 times negative 1 is 3. 3 minus 3 is 0. Therefore, the intersecting point, which is the solution, is negative 1, y equals to negative 1, and x equals to negative 1, and y equals to 0. Alright, sometimes they will not give you a y or x. Then we will have to do something about that. It might not be ideal because cases are strange. We can still use substitution, and then we're going to substitute it now. So, for example, I got 3x minus 5y equals to 11 and 4x plus 3y equals to 5. Definitely I do not have x, I do not have y equals to, so we're going to do something about it. So let's see, we have equation 2, we have 4x plus 3y equals to 5. Now I'm going to change subject to make it y equals to something. So 3y will be equals to 5 minus 4x, and x will be equal, y will be equal to 5 minus 4x divided by 3. Now, because the 3 come from the 2, I need to substitute it to something else, which is the 1. So put 3 into 1. So we have 3y, 3x minus 5 times 5 minus 4x divided by 3 equals to 11. Right, that's annoying, I know it. So we're going to multiply the whole equation, every single term by 3. 9x minus 5 times 4x equals to 33. And then we rainbow it. 9x minus 25 plus 20x equals to 33. Moving on, we continue to do it. We got 29x minus 25 equals to 33. 29x equals to 58. And then at both sides divided by 29, x equals to 2. Sorry, it's not finished yet because we need to find y. So we find x, I put it back to this equation because that's the equation 3 we deduced. So we will have x equals to 2 and y will be equals to 5 minus 4 times 2 divided by 3. So we have 5 minus 8 divided by 3. I got negative 3 divided by 3 equals negative 1. Therefore, the solution is x equals to 2 and y equals to negative 1. Hi. Instead of substitution, we can still eliminate the simultaneous equation. So given two examples, 2x plus y, 3x minus y, one is equal to 3 and one is equal to 7. Alright, so when we check, we'll check on which one. Number one, we check on which one to eliminate. Alright, so looks like 3x, 2x doesn't work. Y and y, yeah, y will be taken to eliminate. Alright, then we think of how to eliminate. So we have y here and negative y here. We want it equals to 0. So what is the operator in the middle? That's what we would be thinking. So we plus become negative. So y minus y equals to 0, which will work. So we will be minusing, but not only the y, the whole equation. So the working will start with copying the question. And then we add them up, the whole thing. So 2x plus 3x equals to 5x. Y plus negative y equals to y minus y equals to 0. So we're not writing it. 3 plus 7 is 10. Now we can continue to solve it. 10 divided by 5 and we got 2. After that, we put it into either of the equation. So 2 times x plus y equals to 3. Since we got x equals to 2, so we can just remove the x and put the 2 in it. Then we have 4 plus y equals to 3. Remove the 4, we have y equals to 3 minus 4 equals to negative 1. Therefore, we have our equation. X equals, therefore, the solution is x equals to 2 and y equals to negative 1. There are situations that we will have a bit annoying equation to work with. So, here is an example. We have 2x minus y equals to 9 and x plus 4y equals to 39. Alright, either way will work because we will do our least work as possible. So this 2 and y, this is x and 4. Either I multiply this by 2 or multiply this by 4. Therefore, I will work with the easier way. I will put 2 times 2. So the whole equation multiplied by 2. X times 2 is 2x. 4y times 2 is 8y. And 36 times 2 is 72. I call it 3. Now I minus the whole thing of 1. So 2x minus 2x is gone, 0. 8 minus negative, I got 9y. 72 minus 9, I got 63. Therefore, I will have y equals to 63 divided by 9, which is 7. Once I get that, I substitute back into one of those. So I have 2x minus y equals to 9. Remove the y, put a 7 in it, because y equals to 7. So 2x equals to 16. X will be equals to 4. Method is different, but you can still get the answer. Therefore, the solution is x equals to 4 and y equals to 7. Just remember, you need to find the x and y to complete the question. And this ends our simultaneous equation practice.